Kevin Simmons is a professor at at Austin College. Professor, right?
Yes.
Yes. Okay. And he is going to be talking about the economics of mitigation, and very excited to hear what he has to say.
I really appreciate it. I am an economist, so I'm a little bit different from everybody that's been up here, and we're going to be asking different questions. And I'm also a new grandfather. So children's literature has become a very important part of our life. And I've discovered that there's a lot of wisdom in children's literature. And so for this audience, I think the metaphor of the three little pigs is going to be a really good one for us to focus on. Because we're going to look at three different things, and I'm going to do extremely quickly and may skip about half of it so we can get to the end. The effect of the recently enacted Florida building codes after Hurricane Andrew, a damage study on hail that I did with a colleague at Horton, and then a most recent study that I've done with a colleague, Paul Kovacs, who's actually here, on benefit cost, because the economist is not interested in can you build something that will withstand an EF5 tornado? Do the benefits of this outweigh the cost? That's the only way we're going to be able to sell this idea. So really quickly, let's just go through. In Florida, Hurricane Andrew illustrated that we had really inferior construction that had happened in Florida in the 10 years leading up to Andrew. Tanya's employer did a study, IBHS did a study after Hurricane Charlie that provided a natural experiment. We could look at the damage for those built after the new building codes and compare that to the ones before. And what IBHS found was that in terms of the claim frequency, the newer homes are 60% less likely to have a claim, and further, if they did have a claim, the claim was 40% lower than homes that were built prior to that. Jeff Sikowski and I, a colleague at Horton, are doing a study right now in the state of Florida where we're looking at the entire decade. Our study is basically backing up what IBHS found. We're finding almost exactly the same results. Now, talking about Jeff and I published a paper a year ago on hail. So Tanya's going to be really interested in this. I think she's actually seen the results of this paper before. But what we did here, we looked at hail because hail is one of the big drivers of insured losses in Missouri. And Missouri, unlike Florida, does not have a statewide building code. However, there is an organization called VERIS that goes in and for communities that request it, they will grade their building codes. And they come up with what they call the BSAGS rating, the Building Code Effectiveness Grading Schedule. And so you can tell the differences in the building code expectations from one community to the next. The BSAGS program has 10 classes based on 100 points. This gives you a national distribution. And this is one of the things that Jeff and I used in our empirical model. Not to bore you, it's an econometric model, so those of y'all that avoided economics in college, we'll just skip right over that. But it's an econometric model that tries to understand what effect the BSAGS rating had on losses. What we found was that, in fact, the better BSAGS ratings do reduce damages. In fact, they reduced it by about 20%. So having the better ratings reduced overall damages from hail by about 20%. Now the economist comes up. It's one thing to say better construction matters, but do the benefits justify the cost? So what we're asking is there a cost effectiveness for the mitigation? So to look at that, we're going to look at a study that Paul and I, along with a colleague at University of Western Ontario, Greg Kopp, did. This was published this year in Weather and Climate Society. It was also the focus of a New York Times op-ed that came out last month. We focus on Moore, Oklahoma. We've talked about Moore, Oklahoma quite a bit already. Moore, Oklahoma regrettably had suffered 3 violent tornadoes in 14 years. The most recent was in 2013, which, as Aaron alluded to, we had some fatalities in a local elementary school. This motivated the city of Moore to adopt stricter standards, to go from 90-mile-an-hour standard to 135-mile-an-hour standard. What did they do? They required narrower spacing of the joists. They required connecting the roof to the exterior walls with hurricane straps. They also required the base plates to be anchored to the foundations with anchor bolts, as you see there. In addition to that, they required wind-rated garage doors, as well as improved exterior sheathing. All in all, the consulting engineer that worked with the Moore Association of Builders estimated that this adds $1 per square foot to the cost of a house. For the typical house in Oklahoma, which is about 2,000 square feet, that adds $2,000. If you were to have built every home in Oklahoma to those standards, the increase in cost would have been a little over $3 billion. So I want you to keep that number in mind, because for the mitigation to be cost effective, the expected reduction in damage needs to be more than $3 billion. So the next phase is to figure out, will we see a reduction in damage to justify that? Now, Mark kind of stole my thunder here, but the codes in Moore were basically get you through an EF2 tornado. 70% of all damage from tornadoes comes from tornadoes rated EF3 and up. But the rating on that tornado is not indicative of the entire wind field. That's the maximum wind sustained across the tornado. In fact, this is an illustration of a typical tornado, and the dark red is the most intense wind field. And as Mark alluded to, that's a small percentage of the overall path of the tornado. A study was done in 2007 for the Nuclear Regulatory Agency on what are the percentage breakdowns on wind fields within tornadoes. And this slide right here gives you that breakdown. For instance, look at an EF3. An EF3 has less than 7% on average of the wind fields in that tornado that would have been rated EF3. This is a slide that Greg and Paul and I came up with, kind of illustrating how that affects your understanding of the damage. The middle column would be the estimate of damage if all you took was the maximum wind, in other words, the rating of the tornado. 23% of all damage would be from EF5 tornadoes, 22% from EF4. But if you take into consideration the wind fields, that changes that column, and you can see that on the far column on the right. Even though 30% of the damage comes from tornadoes that are rated EF2 and less, once you change that to wind fields, 46% of all the damage comes from wind fields that are EF2 and less. Those are the ones that we can build for. We probably cannot build for economically an EF5 tornado, but we can build for tornadoes in the lower range. The Moore codes that were adopted, Greg went through an extensive analysis of the effect that they would have, and our estimate is that 2/3 of all the damage within that 46% can be mitigated with the Moore codes. That translates to a reduction overall in tornado damage of 30%. So the next thing we need to kind of figure out is, okay, how much losses Oklahoma can expect over the next life of a home, say 50 years. We had 25 years of insured loss data for Oklahoma. Based upon that, we extrapolated that into the future to get us an estimate of 50 years worth of losses. Now I'm going to throw in a little bit of finance here. We took the present value of that because we're trying to make a current dollar to current dollar estimate of that. The present value of our estimate of future damage in Oklahoma is $36 billion. If we mitigate 30% of that, that's $11 billion. So keep in mind two numbers. What was the cost? It was about $3 billion had we built every home in Oklahoma to the Moore standards. The amount of mitigation that we can expect is $11 billion. So that gives us a benefit to cost ratio of a little bit of 3 to 1. Now when you do a benefit cost analysis, it's very important that you follow up with what's called a sensitivity analysis, because there's a lot of variability in our assumptions. There's 5 variables that go into our benefit cost analysis. The amount of damage that can be reduced, Greg could have been wrong. The additional cost, the consulting engineers could have been wrong. The amount of future losses. Oklahoma may not have another tornado for the next 50 years. Thank you. But if recent past is any indication, this is what we expect. Also, we had to take into consideration what percentage of the damage was occurring residential, because the Moore codes were residential. Oklahoma Department of Insurance gave us this number: 2/3 of the amount comes in residential. And finally, something called the discount rate. Well, this gives you what our sensitivity analysis will tell us. What does each of these variables have to fall to flip the benefit cost, to make it go from positive to negative? Our percent reduced damage needs to go from 30% to 10. The cost needs to essentially triple. The present value of future losses needs to go down. The residential share of losses, maybe it never hits another house. Maybe it only occurs in commercial buildings from here on out. And the last one, what does the discount rate have to do to change that benefit cost analysis? Some understanding of the potential payout of what the city of Moore did, and makes it sound like a good policy that should be considered for the entire state. For this to be applicable to other areas really depends upon their probability of getting a damaging tornado. You can't say just because it happens in central Oklahoma that it pays off, it's going to pay off everywhere. And that's the next follow-up that we've discussed, is to look at other states to see where the benefit cost analysis will work and where it won't work. So with that, I will close and thank you guys for your attention. I appreciate very much being invited here. Kirsten?